Hello everyone. Welcome to my YouTube channel on engineering mathematics.
In this video, I am going to discuss Maclaurin series and examples based on it. In particularly, we will see how to use Maclaurin series to expand functions of x as a series in ascending powers of x. So let us first see the prerequisite to learn Maclaurin series. In prerequisite, we will recall Taylor series. The statement of Taylor series is as follows. If f of x is a function whose derivatives of all orders exist on a given interval, then the Taylor series of f of x at point x is equal to a is given by summation of x minus a raised to n upon n factorial into nth derivative of f at point a, where n varies from 0 to infinity. When we substitute values of n one by one into this, we get Taylor series of f of x as f of a plus x minus a into f dash of a plus x minus a square upon 2 factorial into f double dash of a, and so on. I hope you remember this Taylor series. You can learn more about Taylor series in my previous video, whose link is given in the description box. Now let us talk about Maclaurin series. Maclaurin series is defined as follows. Note that Maclaurin series is a particular case or specific case of Taylor series. Maclaurin series of function of x is a Taylor series of f of x about point x is equal to 0. That is, if f of x is a function whose derivatives of all orders exist on a given interval, then Maclaurin series of f of x is given by summation of x raised to n upon n factorial into nth derivative of f at point 0. That is, Maclaurin series of f of x is equal to f of 0 plus x into f dash of 0 plus x square upon 2 factorial into f double dash of 0, and so on. Its n plus 1th term will be x raised to n upon n factorial into nth derivative of f at point 0. Now let us proceed with some real examples on Maclaurin series. In this first example, we are asked to prove using Maclaurin series e raised to x is 1 plus x square upon 2 factorial plus x cube upon 3 factorial, and so on. In short, we are asked to prove that series of e raised to x is given by 1 plus x square upon 2 factorial plus x cube upon 3 factorial, and so on. Now let us take a look at the solution. Here we first recall statement of Maclaurin series. Maclaurin series for f of x is given by f of 0 plus x into f dash of 0 plus x square upon 2 factorial into f double dash of 0, and so on. We label this series as 1. Here in this example, f of x is e raised to x. Using this f of x, we will find out values of unknown terms in the RHS of 1. Those unknown terms are f of 0, f dash of 0, f double dash of 0, and so on. So let us find out these values. F of x is e raised to x. So f of 0 will be e raised to 0, and anything raised to 0 is always 1. Now we find out f dash of x. F dash of x will be again e raised to x. Therefore, f dash of 0 will be e raised to 0, that is 1 again. Similarly, we will have f double dash of x is equal to e raised to x. So f double dash of 0 is 1. Similarly, one can have f triple dash of 0 is equal to 1. And this things goes on. Now we substitute these values in RHS of series 1. I am carry forwarding all these values on my next slide. Okay. Now let us substitute these values in 1. So we have f of x is equal to f of 0, that is 1, plus x into f dash of 0. F dash of 0 is also 1. So we have only x plus x square upon 2 factorial into f double dash of 0. But f double dash of 0 is also 1. So we write only x square upon 2 factorial. Similarly, you can have next term as x cube upon 3 factorial plus x raised to 4 upon 4 factorial, and so on. Look at this. This is the required series of e raised to x, and this we achieved using Maclaurin series. I hope you understood this. Now I have similar practice example for you. Here I ask you to prove series of e raised to minus x is 1 minus x plus x square upon 2 factorial minus x cube upon 3 factorial and so on. Now let us go for example number 2. Here I ask to prove using Maclaurin series of sin x is x minus x cube upon 3 factorial plus x raised to 5 upon 5 factorial minus x raised to 7 upon 7 factorial and so on. Let us see solution part. First we recall Maclaurin series. Maclaurin series for f of x is given by this. We label this series as 1. In this example, f of x is sin x. Using f of x, we find values of the unknowns in series 1. So here f of x is sin x, then f of 0 will be sine of 0. But sine of 0 is 0. So f of 0 is 0. Next, f dash of x will be cos x. Therefore, f dash of 0 will be cos of 0, which is 1. Next, we find what is f double dash of x. Derivative of cos x is minus sin x. Therefore, f double dash of x is minus sin x. Therefore, f double dash of 0 is minus sin 0, which is 0. Similarly, f triple dash of x will be derivative of minus sin x, which is minus cos x. Therefore, f triple dash of 0 will be minus cos 0, which is minus 1. Similarly, you can find out further values. Now we substitute these values in RHS of 1. Let us carry forward all these new values. Okay. Now after substitution in series 1, we get f of x, that is sin x, is equal to f of 0, which is 0, plus x into f dash of 0. F dash of 0 is 1, so we get only x here, plus x square upon 2 factorial into f double dash of 0, but f double dash of 0 is 0, so this term becomes 0. Next term will be x cube upon 3 factorial into f triple dash of 0, but f triple dash of 0 is minus 1, so we have minus x cube upon 3 factorial. On the similar lines, you will have next term will be x raised to 5 upon 5 factorial minus next term will be x raised to 7 upon 7 factorial and so on. And this is how one can prove series of sin x is x minus x cube upon 3 factorial plus x raised to 5 upon 5 factorial and so on. I hope you understood this example. Now I have similar practice example for you. Here I ask you to prove Maclaurin series for cos x is 1 minus x square upon 2 factorial plus x raised to 4 upon 4 factorial minus x raised to 6 upon 6 factorial and so on. Please write me in comment box whether you are able to prove this series or not. Now let's go ahead for last example. Here I ask you to prove using Maclaurin series for tan inverse x is given by x minus x cube upon 3 plus x raised to 5 upon 5 minus x raised to 7 upon 7 and so on. Let us prove this. Look at the solution. First we recall series of Maclaurin, which is given by f of 0 plus x into f dash of 0 plus x square upon 2 factorial into f double dash of 0 and so on. Label this series as 1. In this example, f of x is tan inverse of x. Using this f of x, we will find out these unknowns in RHS of 1. So let us first find out f of 0. So f of 0 will be tan inverse of 0, and we know tan inverse of 0 is 0. Next we find out f dash of x. Derivative of tan inverse of x is 1 upon 1 plus x square. So f dash of x is 1 upon 1 plus x square. Now we find out what is f dash of 0. So f dash of 0 will be 1 upon 1 plus 0, that is 1. So f dash of 0 is 1. Next we find out f double dash of x. F double dash of x, you will see, is equal to minus 2x upon 1 plus x square the whole square. You can pause the video and check this calculation. Next we find out f double dash of 0. So f double dash of 0 will be obviously 0 because in numerator we are getting 0. Now we find out f triple dash of x. You will see it is equal to minus 2 into 3x square minus 1 upon 1 plus x square whole cube. Therefore, f triple dash of 0 is equal to minus 2. Similarly, you can find out further values of derivatives of f at 0. Now I carry forward all these values and then we substitute them in series 1. So after substitution, at LHS we have tan inverse of x because f of x is tan inverse x, and on RHS we have f of 0 which is 0 plus x into f dash of 0 which is 1. So we have only x as a first term plus x square upon 2 factorial into f double dash of 0, but f double dash of 0 is 0. So this term becomes 0. Next term will be x cube upon 3 factorial into f triple dash of 0, but f triple dash of 0 is minus 2. So we will have next term as minus x cube upon 3. Similarly, you will see further calculation will give us next term as x raised to 5 upon 5. After that, we will have minus x raised to 7 upon 7 and so on. So this is how one can find out series of tan inverse x using Maclaurin series. I hope guys you understood this example as well. Now I have a practice example for you which is similar to this example. Here I ask you to prove Maclaurin series for log of 1 plus x is equal to x minus x square upon 2 plus x cube upon 3 minus x raised to 4 upon 4 and so on. I hope you will prove this series also. Please write me in comment box whether you are able to solve these practice examples or not. In my next video, I'll be coming with more such interesting topics. Till then, keep watching my videos. Thank you all of you. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.